my name is Henrik Mortensson. I have yet another management video for you. Now, as usual, this video is mostly made in my favorite cafe, with coffee. I asked a friend of mine who manages an IT department what he thought would be a useful topic for a management video. Now, it's a good thing I did, because I was going to talk about something completely different and probably a lot less relevant to you. So what he wanted to know was how to solve the problem with unreliable time estimates. Software developers usually hate to make estimates because it's difficult to do, and managers hate estimates because they are almost always wrong. So, is there anything we can do about it? As it turns out, there is. The problem with estimates in software development is not that estimates are bad per se. We're just using them in the wrong context, and sometimes, and even most of the time, we are using them when we don't really need them. So we'll talk about the right and wrong context first. The project management expert Bent Flyvbjerg, who is also an academic researcher, has built a database with thousands of projects. Now, what he found was that estimates work pretty well for some types of projects and not at all for others. For example, if you know how long it takes to build and install a wind turbine, you can easily estimate how long it takes to build 10, 50, or 100 wind turbines. On the other hand, if you know how long it took to build a nuclear power plant, you still have no idea how long it will take to build another. There are too many variables that can vary wildly. Unfortunately for us in the IT business, creating software is much more like building nuclear power plants than it is like building wind turbines. So before we try to fix the problem, it would be nice to have a way to measure how well estimates work. As it turns out, this is very easy to do. Imagine that we have a coordinate system. On the x-axis, we have our estimates. On the y-axis, we have how long it actually took to do the job. Now, this is called a scatter plot, and you can easily create it in Excel or whatever business intelligence software your company is using. In this demonstration, I'll go with Excel. So, we can extract the data we need from Jira or Azure DevOps or almost any other project management or lifecycle management system. And the easiest thing is usually to do it as CSV files, comma-separated value files, because we can import those into Excel. There is one thing though, you should import the CSV file as a data source, because then Excel will handle the conversion correctly. I found that converting the CSV file by opening it using file open can mess things up. Also, I recommend you use Excel 2019 or later, or you may get problems. If our estimates are perfect, estimates and real durations will always line up in a straight line, like this. Now, of course, we would expect the line to be a little bit wobbly, because there is always a bit of uncertainty. What you are more likely to find is that the diagram looks like this. There is no line. What most people do when the estimates don't work is to try to refine the estimates. They put more and more effort in trying to find that line. The more they try, the worse it gets, because there is no line. If you have seen The Matrix, you may recall the scene where Neo sees a child bend a spoon through sheer power of will. The child tells Neo that there is no spoon. It's the same for us. For the third time, there is no line. The system we are trying to predict has a lot of randomness built in, and that makes it impossible to estimate accurately. So the problem is not that we are bad at estimation. The problem is that estimation is the wrong thing to do. What should we do instead? Well, first we figure out whether we need to know the duration or not, and you may be surprised. Second, if we do need to know when something will be done, we make a prognosis, not an estimate. I'll show a simple prognosis method named reference class forecasting in this video. One of the most common reasons for making time estimates is that a Scrum team is doing sprint planning and Scrum sprints are time boxed. According to the Scrum Guide, we must predict what can be done in the upcoming sprint. So why do we need to do that? The Scrum Guide doesn't say why, it just says we must. But do we? Let's consider what happens if we do not estimate how much work fits into the sprint. So the developers don't spend time on estimation, which means they get a little bit more time to do other things, for example, software development. Okay, so we gain a little time. Do we lose anything? Well, we will not know how much work we can do in a sprint. Does that knowledge have much value? Obviously, if we do estimate and the estimates are wrong, we don't know how much work we can do in a sprint anyway. So the question is really moot, but just for the sake of the argument, is there value in knowing how much we can produce in a sprint? So, okay, we work with some kind of vertically sliced requirements like user stories or maybe use cases. We thin slice them so each vertically sliced work package is as small as possible because this improves flow and makes it more likely the team will finish something during the sprint. Suppose we just start working without knowing how many things we will finish. Well, we finish just as many things we would have finished if we had made the time estimates. Maybe a few more because we had more time to develop software because we didn't spend time estimating. So we lost nothing. In this situation, spending time estimating would not have benefited us, even if the estimates were correct. But wait a minute. Isn't there supposed to be psychological advantages to time boxing? What's usually mentioned is that we can fight procrastination and we can focus on work that matters and we can get the feeling of achieving something complete and meaningful. And yes, time boxing can be a great focusing technique, but it hinges on being able to determine the size of the time box. The problem here is that we cannot estimate how much work will fit in the time box. What's worse, we will often underestimate how long work takes, which will lead to 1. Pressure to do shoddy work. This causes technical debt to build up, and technical debt is economic debt. It will have to be paid sooner or later and with heavy interest. And we have psychological pressure. What happens to people when they miss the mini deadlines that they have set for themselves and they do it over and over again? It's not good. Fairly often, I see teams that are thoroughly demoralized because they feel they can never catch up. People feel personally responsible for a problem that is out of their control. So, in an environment with a lot of inherent uncertainty, like software development, time boxing can easily have the opposite of the intended effect. It's also worth noting that we are already using other mechanisms that help us fight procrastination, focus on things that matter, and achieve something meaningful. Vertically sliced units of work, like user stories, features, and use cases, do exactly that. They represent working software and thus are units of real progress. Pull processes, in combination with vertically sliced requirements, reduce the stress. Developers have a well-defined short-term goal to work towards, and at the same time, they are in control over the amount of work they take on and when they take it on, and can work at a sustainable pace. Now, if we time box, we can actually torpedo all that. So, we come to the unpleasant conclusion that the whole idea of estimating work during sprint planning is one giant brain fart. 1. It doesn't work. 2. Even if it did work, it has no value, it's just wasted effort. 3. The psychological effects can be very negative. And 4th, we already have other mechanisms in place that function much better in high variation processes like software development. And 5, if we try to use those mechanisms at the same time we use time boxing can torpedo them. On the other hand, Being able to predict duration and cost has a lot of value in other situations. For example, we may need to predict how long it will take to build a piece of software in order to coordinate with a team building something else, like a piece of hardware. So we may also need to predict not just how long it will take to build something, but also what it will cost. Now, can we do that? And yeah, we can. So I'll show you how, and after that we will discuss constraints. There are some things that need to be in place for this to work well. Here we've got an Excel spreadsheet. I have imported data from Jira or Azure, and this is from a small team with a pretty well-behaved process, and they are using user stories. And since for this demonstration, I'm sticking to very simple reference classes based on the requirements model. So I won't try to refine the model here. As you can see here, I have sorted the data from largest to smallest. The whole thing works very well, even if I don't, but it's nicer for me to see, and there are other tricks I can do if I sort the data. Here we've got a correlation coefficient, and that's just a measure of how well the estimates fit with actual lead times. 0 means no correlation at all, and 1 means perfect correlation. 0.43, that's actually pretty good, but it's nowhere near what you need in order to use estimates to actually predict something. I have the minimum value here. Note that I'm using the aggregate function. Throughout this line, I'm using the aggregate function whenever I can. And the reason is that the aggregate function that supports lots of different statistical functions. So the 5 here means it's the minimum value. Here it's a 4 for maximum value. Here it's a 1 for lead time. And the reason I'm using aggregate is that it works if I filter data. So I'm not going to do that this time. I have another organization that I will show you where we'll do a little bit of filtering. If I use the built-in minimum, maximum, average functions, they don't work when you filter data. So that's why I'm using aggregate. Now, the important stuff, that's these percentile functions. If I want an answer and want to be 50% accurate, well, then I would go here. I use the aggregate function. Function number 16 is the percentile. 5 here means ignore data that has been filtered out. And then we've got the lead time column in the table. And 0.5 here means 50%. What this says is that I can have 50% confidence in my answer if I say it's a user story will take 4 days to implement. If I want to be 70% sure I'm right, then the answer is 9 days. And you can see here we've got 0.7 for 70%. And here it's 80%, then it's almost 13 days. So it's 0.8 over here. And with 85% accuracy, which is what I would normally go for, then we got a bit more than 16 days. Now we'll look at a more complicated case too. This is from an organization that has a more complicated requirements model. We'll have a look at it here. You can see in the data we've got bugs, we also got epics, features, and user stories. And so what we can do here is we can select something. For example, if we want to know how long it takes to fix a bug, then we select the bugs. So we filter, and 50% accuracy, 11 days. 70% accuracy, well, 27 days. And if we want to be 85% certain, then we won't promise anything below 72 days. That's a lot. We will also look at features, and we'll see here that 50% certain, 894 days. With 70% certainty, 910 days. And with 85% certainty, 1284 days. And that's 4 years. Now, this can happen in organizations that use waterfall, agile, hybrid methodologies, and it can happen if you have poorly implemented SAFe, for example. And the reason why it happens is that you lose control over your work in process, which means that work just builds up in queues and doesn't get finished. And that is that's built into the system. That's it, really. It is that simple. So, is it really this easy? Have we now solved a problem that has plagued project management in general and the software industry in particular for many decades? Well, reference class forecasting was actually created by Nobel Prize laureate Daniel Kahneman more than 20 years ago. Bent Flyvbjerg, whom I mentioned in the introduction, has spent a couple of decades refining the idea. And there is another method, Monte Carlo simulation, that has been in use in project management since 1963, when Richard van Slyke wrote a paper on it. It's important to understand that while reference class forecasting is simple, it's not necessarily easy. There are a couple of preconditions that should be fulfilled or that must be fulfilled. First of all, you need to have enough information to create reference classes. If you have a requirement system based on user stories, features, capabilities, and epics, then you have a very good start. The catch is that many organizations just randomly assign one of those names to whatever requirements they have without understanding how user stories, features, etc. are supposed to work. So when companies do that, they end up with a lot of junk data in their databases. For example, I often see user stories that are really tasks and not vertical slices. And that makes them unusable for reference class forecasting. Another common problem is that teams doctor data about estimates during a sprint. It's an honest mistake. They believe it allows them to plan better. But what it really does is create junk data that makes their estimates look better than they actually were. It's also common that people, being human, neglect to keep databases up to date, so it's impossible to tell when a decision was made to build something, when work started on an item, or when it was finished. There is no way to get the prognosis capability you want without fixing such basic errors first. You also need a balanced system. If queues keep growing all the time, predictions will be off. I'm looking at use Scrum. Scrum allows the product backlog to grow to infinite size. And this was okay back in 1993 when Scrum was first created, because the intent with Scrum was to solve a completely different problem, churn. And Scrum did that and did it very well. However, Scrum is not good at solving lead time problems. The know-how, queuing theory, and the practice limiting work in process in the system as a whole just aren't there. So you need to go a bit beyond Scrum and put WIP limits on the product backlog. And while you're at it, you can remove the sprint backlog since you're not time boxing anymore. Finally, one of the reasons we get into trouble with estimates that do not work is that for more than 60 years, most people haven't bothered to set up a scatter plot or calculated a correlation coefficient. We've had Microsoft Excel since 1995, and before that we had VC Calc since 1979, so we could have done it for several decades. We just kind of missed it. Now, if you start using reference class forecasting, please don't do the same mistake. Follow up. Scatter plots and correlation coefficients are your friends. Use them. Otherwise, you won't know if everything works as expected or not. So be aware that the more variation you have in your data, the more data points you need in order to see if everything works as intended. And finally, thank you for listening.